Welcome back. One more video about surface integrals. Let's calculate surface integral. Look how beautiful, by the way. I'm trying to make it beautiful integral, but then S also looks like integral, so it's nice to put some heads around it. F, that depends on x, y, z, so it's a four-dimensional object, right? ds, and we have y equals 6 minus z squared. X is non-negative, z is greater or equal than 5, and f equals z. First of all, let's figure out what are we talking about. First, remember that this function will go inside of the integral. Don't touch it yet. We will use it only when we actually multiply things. ds is what's everything else. ds is talking about these relationships. So let's try to visualize what is happening with ds and s, right? What is your s is doing? Y equals 6 minus z squared is the parabola, but instead of x we have z. So not only we know it's three-dimensional object, and parabola in 3 dimensions called paraboloid. So I actually decided to check it out, and I plotted using GeoGebra. Here's my paraboloid. Instead of looking up like we got used to it, we usually feel like, oh, that should be like this. Paraboloid like a hat, right? Looking up. But because it's using z instead of x, it is actually lying down. So x-axis is my axis. Oops, I did not know it can do that. X-axis is my axis of rotation. How to put it back to the normal view? Oh, thank you. Good job. Oh, that is so cute. So let me zoom in. I wanted to draw the line that x-axis is the axis of rotation, while z is blue. You see, it's going up, and y and z together creating this paraboloid. So here's the picture, and it's not going infinitely because x and z have a lower limit, lower bound. X is bigger or equal than 0, so only positive for 0. Z is less or equal than 5. This is what I wrote here. Oh, see, I made a mistake. Z should be restricted up until 5. So anyway, I made a very nice screenshot of this picture. Here it is. See how it looks like? Let's fix the typo I made. It should be less or equal than 5. So it's upper bound. Lower bound for x and upper bound for z. Here it is. This is nice looking paraboloid, where again x-axis is the axis of symmetry. Where does it look? It looks down like this. No, actually on their picture the first try was correct. This is like that. Okay, now we know what's happening. So let's figure out the parameterization, and this is where people stuck. I mean, no wonder, because it's a complicated topic. Solution. Step 1, we need to figure out parameterization, right? Parameterization R, we're using U and V recently because we're working with surfaces. So I see y equals 6 minus z squared, right? Then why not to make it simple and choose? So parameterization will also make a choice. X to be U and then Z to be V. Why? Because you might not see it right away, but Y depends on X and Z. So it's 6 minus Z squared plus 0 times whatever is X there. Maybe X cubed, X5, whatever. Doesn't matter, it's multiplied by 0. So to make your life easier, it makes sense to choose, to basically keep it as X and Z. You don't even have to rename it if you don't want to. But I do recommend to do it. It's less confusing this way. No, not always. Then, guess what's going to be Y? Y will be 6 minus V squared. It's kind of dumb, to be honest. You can just keep it as Z squared. That is totally okay. Or keep it as y equals 6 minus z squared, then you just name x equals x and z equals z. So again, parameterization is not unique. That's what confuses students so much. It's a creative process. Okay, so just be okay with that. Mathematics is pretty creative. Okay, then if we have that, we have our parameterization. Step 2. Now we can start with taking derivatives, if you remember. So we're gonna have partial derivatives. R, again, is x, y, z, right? So we just have now parameterization that x, y, z depends on u and v. U times v, not times, u comma v. What is my f? F equals z, so that will be literally v, or just keep it z. That is okay. But then what about partial derivatives? We're gonna find r with respect to u and r with respect to v. But what is r? R of u comma v is 6 minus z squared. That is so confusing, right? Basically, we just matching this. This is our parameterization. So we don't need to kind of reinvent a wheel here. It's already given. So just keep it as 6 minus z squared or v squared. So yeah, it's a kind of dumb way to do it, but it works. So let's just do that. In general, I would even say that in this particular case, r depends on x, but y depends on x and z. So that's how we went from 3 variables into 2 variables. So r can be written as function of x, z only, because y is written in terms of x, z. So basically this example is just harder to explain what's happening with parameterization. But other than that, it's not too bad. Let's find r with respect to u is 0. R with respect to v is minus 2v or minus 2z. You can have it as well this way. Put it in the box we need. Now you have 2 rows. Step 2 is done. We found derivatives. We have 2 rows to choose from. Let's think about it. Is this an integral over vector field or over a function? Reminding you, we had, so this is the example I showed in my other video about flux. Definitely watch that. But my idea was in these 2 videos is to compare those 2 formulas. Okay, now they are super damn messy. So maybe I just erase everything. Here it is. 2 different formulas. Surface integral over f and over f. Okay, but one f is capital and one f is not capital. That's also not the right way to remember it. One is the vector field. So the vector field one has cross product, and that is a normal vector, and orientation of the f vector field matters. The other one is a function. So we are given the function. It's actually equals to z, if you can check. It's a small f. And they never mentioned flux, they never mentioned orientation. That's how also you know. So we're choosing this formula. So now you can start to find cross product and then find the size of it, blah, blah, blah. But actually there's a shortcut. We do know one more formula, and this time I will use it because other examples you most of the time with the cross product, and it's just kind of boring to keep doing it. Instead of doing this formula, we have f. So f there is just no matter what formula you use, that f is there, capital or not capital, but it's there. But then the tail can be different. There's a formula that has a square root 1 plus, let's not call it f anymore, so it's going to be, in the previous formula it was called f. 1 plus, say, ru squared plus rv squared, like so. And then it's going to be du dv. Or you call it dx dy in the previous formula. Doesn't matter, your job is just to know which one to use. And then this is over s. That's actually over d. So it's a shortcut. This way you don't have to find cross products. Isn't it awesome? If you already have function giving so nicely as we have here, y equals blah blah blah, or f equals blah blah blah, then we can use this formula. So the square root of 1 plus ru squared plus rv squared will be a square root of 1 plus 0 plus negative 2v. Both, okay, I should need more pretty. Both are squared. 0 squared plus negative 2v squared. So that gives me a pretty nice answer. And this goes inside of the integral with a tail at the end, du dv. So this is 1 plus 4v squared. And we're using this formula, integral over s. It's one of the formulas. I would say you don't have to remember it, but it definitely speeds up the process if you can use it. ds can be written as double integral over d, so we're going to domain f. In this case, we have, well, the same, this f, which were rewritten, right, in terms of u and v. And then there's a square root of 1 plus r squared with respect to u and r squared with respect to v. du dv. So this is what we're using. Let's put it in a beautiful box. Can you finish this example faster than me? Then we can compare the answers. Like this. Good. Actually, it's nice if you pause right now and finish the example by yourself. Equals double integral. Okay, f. Did we ever found f? Root. We forgot to found f. It was given as z, so we can keep it as z, but we decided to rename it to v. So let's have v. So we have v. Then, now let's put it in a different color so you can recognize it later. This is the v, right? Then we have the square root. Oh, let's put it also in different color, purple, to be consistent. 1 plus 4v squared du dv. And now we just need to figure out what is happening with those u and v. Well, u is x. That's why actually it's not necessary to go that route. X is greater than 0. So for now, let's put it, u is x, right? So let me make a note. X is greater than 0. So from 0 to infinity, which is, by the way, not correct. But let me keep it for now, right now. Now, how about z? Z is less or equal than 5. So from minus infinity to 5, I guess? That's v, right? To 5. And this is now we have to figure out if this is correct. The thing is, we're talking about d. This is the one I wrote over here. Let me change it to yellow. Here it is. We're talking about this d. That's called domain, right? Domain. And domain is actually, that's the domain of integration, if you want to be more specific, of integration. Integration. It's a square. It's a square. 0, 5 by 0, 5. Can you figure out why? And also, what are those 0, 5? That is in xz plane. Because remember the picture? The domain x and z are inputs. Y, this is y. Is it y? Yeah. Are outputs. Actually, let's check again. This Desmos, no, GeoGebra, I'm not actually sure how it sketches things because I did not use it before. So 0, 0, okay. Looks good to me, but it would be very polite if they ever sign it. I think green is X and Y is red. Okay, I guess it's fine. We can just assume that is the case. So, I mean, there's a correct answer. I'm just kind of too lazy to dig into it. My point is, how do we know it's a square? Why did it go to infinity? Because y restricts those two. Y has a relationship with 6 minus z squared. Z cannot go larger than 5, right? X is just equals to or 0, so that is a floor. Thus, we can figure out that if I'm thinking about z and x plane, we have x equals to 0 or bigger than 0. That is this plane, right? First and fourth quadrant. But then z is less than 5 or equal than 5. So I put this line. Z have to go equals to 5. Go down forever. So that is not a square 5 by 5, as I mentioned before. But then we can say that z, let's see, 0 to 5, 0 to 5. X is positive to the right. Z is negative, less than 5. So this is 5xz plane. Yeah. Then y is 0 when z is a plus minus square root of 6. Okay. How can they claim it? Maybe I missed something in the definition. Why the domain is a square from 0 to 5 and 0 to 5, x and y, x and z. So they claim that x is going from 0 to 5 and z is going from 0 to 5. And because x and z are literally u and v, then we can just put it from 0 to 5 and 0 to 5. If you want to just finish the homework, that's literally the answer. This is the integral we need, and then you calculate it using u substitution, which let me do right now, and then while I'm doing it, maybe I'll figure out the answer. U substitution, let be quick, is, okay, now let's not use u and v. That's actually a very clever thing to mention. Let's not use u and v. It's not like it's reserved. It's not u substitution. It's just substitution. So you can use any other variable. Let's use, w, not very creative, but why not? You can use t, m. Oh, m is cute. Let's do m. M, sometimes they use u1, u2, is 1 plus dv squared. Then dm is 8v dv, right? See, I like to put hats so it looks beautiful. This is my u sub. You can change limits of integration, or you don't have to if you know how to do it quick. Also, remember you're solving for this, so I'm going to divide by 8. Remember how it's done? You divide by 8. Equal sign, and I have integral 1/8, because I'm dividing by 8. And I have a square root of u, it's not u, remember it's m. And then I have dm. Okay, now what the heck did I just do? We have double integrals. Why I'm doing u substitution? With which variable am I working? Well, I'm actually working only with v variable. That means I'm just doing this inner integral. What is happening with the outside integral? The outside integral is a constant because, I'm working with dv integral only. And the outside integral will be the integral, which I can write down for you, integral from 0 to 5 du. That's just 5. It's always the length of the interval in this case. For m, either you change limits of integration, 0 gives you 1, and then 5 you plug in and get the answer, or you don't. Many people just don't do that. We just kind of remember that v was 0 and v was 5. So when you go back to the original variable, you just plug 0 and 5. Equals 1/8 Square root of m, integrating that gives you m, and I'm immediately gonna rewrite m as 1 plus 4v squared raised to the 3 halves, right? So it's 1 half becomes 3 halves divided by 3 halves. Bar from 0 to 5, remember we plug v, times, and the blue part is 5. That's the integral. Now, the final answer, carefully plug 5 into v and 0 into v, and you get this answer. So it's gonna be, I need to simplify this, 3 halves, this flips, 2 cancels out with 8, becomes 1 quarter, blah, blah, blah. So 10 over 3, oh, 10 also simplifies nicely. So annoying. I just see the answer, but I guess I can simplify with you. So it's 5 over 8 times 2/3. Nice. And then we have the inside part. When I plug 5, it ends up to be 101 3 halves. But when I plug 0, it ends up to be 1. Like this. I think that is correct. Simplifying, it's 10 over 24, or I can simplify 4, blah, blah, blah. Anyway. Well, actually, this is a good answer. Let me just finish it. I am too lazy recently. 5 over 4 times 3, 12. And then 101 3 halves minus 1, which is approximately 422.506. That's the idea. This is how we finish integration. That was a surface integral, but not with a vector field, with a function f. And still the part about the square, did you get it? The part about the square? So y depends on x and z. X and z are restricted. Oh, I understood. I understood this is a fault of the book. This is so dumb. I'm so upset about this right now. It is their fault. People don't do it this way. This is how it was written originally. Go away. Let me fix this typo. This is how it was written originally. X is greater than z or equal to 0. Z is less or equal than 5. Well, what they mean is, no, they mean it this way. They mean x, comma, z. And both of them are from 0 to 5. Duh. I don't know. People usually don't write it this way. As I can remember, I guess it depends on the country. X is from 0 to 5. And z is from 0 to 5. When that's obviously a square. Duh. Okay, then I probably should fix my Desmos, my GeoGebra thing. That's so stupid. Okay, whatever, fine. 0 less or equal, and then x is 0 less or equal x less or equal, what was it? I already forgot. 5, same thing. And then like this. Okay, well, okay, fine, not really changed anything, but you got my point. You got the point. Both of them are from 0 to 5. That's why it's a square. So let me fix my note. See, I would never write it like this. This is so confusing. Why would you write it as a comma? Anyway, let me fix it. Domain, because, draw. Domain of integration is x is between 0 and 5, y is between 0 and 5. Not y, that's z. Ta-da! Well, that is obviously a square. Where was my graph? Which I was confusing myself. Where is that beautiful sketch? Ah, here it is. Beautiful, ironic, it's like, not really. Here it is. Both x and z are from 0 to 5. That's a square. And that's why the domain is not from 0 to infinity, whatever I was writing before. It's from 0 to 5 and 0 to 5. Duh. That's kind of obvious. Okay, I'm glad we found a mistake, which was not a mistake, it's just notation problem. You see, notation matters. Some notations are more confusing than others, and why would you make a confusing notation? I hope it slowly clears up for you. This important fact is the difference between two formulas. This time I used this formula, which I was teaching in the surface area. No, parametrization, I think. Parametric surfaces. I think we were teaching it here. Or at the very beginning. The formula of 1 plus blah, blah, blah. I think it was maybe at the beginning here. You can try and see if you get the same result if you actually perform cross product. Anyway, I just wrote formula for you, so why even bother looking for it? Here it is, with a square root at the tail instead of the cross product. But you can try to find cross product and see if the answer matches. Thank you for watching and good luck on the final exam.